So, once again, hello and welcome in Refinitiv academic courses. My name is René Steflik, and I am Customer Success Specialist based in Prague, Czech Republic. And today's course is dedicated to the new possibilities in the management of real-time distribution system that many of you will also know as TRAP via HTTP and REST API protocols, and about the benefits that management over REST API brings and offers to customers. In today's webinar, I will be your host, and I welcome presenters who are my colleagues from development team, Parivat and Xiaoming. This class is recorded, and during this presentation you can raise questions over the chat, and at the end of presentation we will try to answer them. And we come to our agenda. The subject of today's course will be following. The first point, we will just shed light on high-level view of RTDS infrastructure or architecture. In the second part, we will say a couple of words about overview of nowadays used tools and RTDS management. As a third point is the introduction to the REST API resources used as a new way of RTDS management. The fourth point is about how is secured the REST API communication and the data handshake. And at the end, Parivat and Xiaoming will show you the live demonstration and some examples how to define and how to call REST management requests. The presentation over to you, Parivat.
Hello everyone, my name is Parivat Pongpesaj, RTDS software developer. Today I am going to talk about the REST interface in RTDS. First of all, let's go over the current architecture of RTDS a little bit. As you can see, we have ADH and ADS sitting on the RCP backbone, talking through the RCP daemon. In ADH, we have channel threads enabled, talking to the SAT application. And we have item threading in both ADH and ADS. In ADS, we also have writer threading for sending out data. And recently, in RTDS version 3.5.1, we introduced RTC, Refinitiv real-time connector, previously known as ADSPOP. Basically, we take the top half of the ADH and the bottom half of the ADS, combine them together, getting rid of the multicast RCP transport, and we get the TCP in and TCP out connection only. In RDC, we also have item threading and writer threading. And in the upcoming 3.5.3 version, we're gonna start supporting channel thread as well. Today, if we want to monitor RTDS component, I would have to jump onto the box where I run ADS and ADH, and I have to execute adhmon to pull up the shared memory data, which is kind of a drawback because I have to be physically on that box. That means I cannot do it remotely. That's kind of the main reason behind the REST API. So starting in version 3.4.0, we introduce REST API. The key benefits and feature of the REST API is basically we enhance the RTDS management capability. It allows remote monitoring because I can monitor the RTDS component from any other box as long as I have access to the box where I run RTDS component. And we leverage HTTP REST standard. That means I can pick any library off the shelf and get it going pretty easily. And we also support JSON format. We also support encryption to the REST API, which is HTTPS basically. And we also have some security mechanism, authorization, IP whitelisting, and REST auditing. For the data flow, it's pretty simple, right? So I can have a web client application sending a HTTP REST request to the REST server, which is built into the RTDS component. And the RTDS component will send a HTTP REST response back to the client for the resource that the client is interested in. And I should mention that the REST server is executed by a separate REST thread. And so we have its own thread to handle all REST incoming and outgoing messages. And we categorize the REST resources into 3 different groups. We have configurations, shared memory resources, and item database resource family. We're gonna go over into more details later in this session. The first REST resource is the configuration. So I can retrieve all configurations from a running RTDS component through this URI. So I send a /config REST query to the server, and then I will get the whole configuration back. Or if I want a single config parameter, I can do so by requesting /config/parameters and then specify the parameter name. The second resources that we provide is shared memory. The first one is probably the most typical use case. Right? So if I want to retrieve all shared memory information, I can request for /sharemem resource. It's going to return the whole shared memory data. The result should be identical to adhmon-mapprint. Or if I want a single shared memory variable, I can specify the class name, instance name, and variable name. And then I will get a single shared memory variable back to the response. So basically anything I can do with adhmon today, I should be able to do from the REST API as well. And the last one is item database. This resource is equivalent to cache dump and database dump. Typically, I have to go to adhmon and then trigger database dump to get the information of our item in the cache. But with REST API, I can just request /itemdb/cache to get the cache data of all items. Or if I want the database information, I can send /itemdb/state to retrieve the item state information. Or I can be more specific by specifying the service name or even item name to retrieve the specific items. And this is not really related to REST manageability, but we leverage the REST API server to support snapshot requests. Starting in 3.5.0 version, we introduced the REST snapshot server. So if I want to get a snapshot data of some items real quick, I can bring up my web browser and then send a request to the server, and then I get the market data back pretty easily. I don't need any API or anything. I just need a web browser or any web client application. Then I can get a snapshot data pretty easily. And the snapshot server is only available in ADS and RTC, similar to where I can request market data from ADS and RTC through SSL and SSL connection. And it supports DAX. If I have DAX enabled on ADS, I have to specify username, position, and app ID. Optionally, I can put the request data in the message body. So if I want to do a batch request, which means I have to specify multiple item names, or if I want only some view, I can specific view in the message body, and then I can specify QoS, worst QoS in the message body as well. And we're gonna talk a little bit about security mechanism built around the REST API. We have security key. Yeah, we can think of it like a password. So I can only access the REST API resources if I have the password. Without the password, I am not authorized. So in the configuration file, I have to put the obfuscated security key. And then when I send a REST query, I have to specify the key in the request. And it's pretty flexible because I can go with different security key for each REST resources. For example, I can use one key for the itemDB resource, and I can use a different key for the configuration resources. Or I can even have a different key for get and put method. It's pretty flexible. So this is how I specify the security key in the URI. The next one is the REST encryption. So the REST interface support encryption. So it's more secure on the wire. And then this is all the configuration parameter related to the encryption functionality. So we have to set connection type to 1. And then we have to specify the server certificate and private key. The next one is IP whitelisting. We can, it's a comma separated list. Only IPv4 is supported for the time being. And then I can specify an IP range, or I can do with the wildcard with the star. So this is some examples. So basically, if we know that I'm gonna send the REST query from a particular machine only, I can specify that machine IP address to be more secure. And the last one is REST auditing. So this functionality allow me to track the REST incoming and outgoing activity. Because if I were the admin, I would like to know how many REST resources have been requested and responded. So this is some example in the log file, REST audit log file. I can see that at this time, the server received /config resource query, and the response was successful. HTTP OK 200. So I know that what's going on with my REST API. And this is how we configure the REST API. I can run tconfig REST and then tconfig /a REST port. And to configure the security key and to configure the REST snapshot, I can use this tconfig command. And then we're gonna get into the demo. Allow me a second. I'm switching the window. And here I have my ADS and ADH running in my lab. So this is my REST API configurations. I have to enable the REST server, and then I specify AT, the REST port, and I also enable REST audit to track the activity of my REST API. And then I put a security key in the config file. This is the obfuscated security key. So let me run a simple curl command, get the config resources from the REST API. We try it without security key. So I will get an error. Security key was not provided. And if I specify security key, I should get a response back. My key is private. Here we go. So this is the configuration result in JSON. Yeah, I should be able to do the same to my ADH. And then I can try requesting for a single config parameter. And I should get the value of that configuration parameter back. Transport type is RCP. And I can try sending some shared memory resources. This one. To specify security key. And then I get the whole universe of the shared memory key back. This is equivalent. This should be identical to adsmon-mock print, but I getting it back in JSON. And I should be able to send a REST query from web browser as well. So let me switch to my web browser window. Right. So this is my web browser, Chrome. So I should be able to send a REST query from my web browser to my ADS. Let's say if I want to request for a database dump. Sorry, I have to remove the curl command. Okay, then I have to specify security key. Here we go. This should be identical to database dump result. But traditionally, I had to jump onto the box where I run ADS and then go to adsmon, trigger database dump. Then I have to download the database dump back to my machine. But with the REST API, I can do it remotely from a web browser or any web client application. This is the database dump, and then I can get the cache dump, my ADS as well. So it's pretty straightforward. Yeah, I think that's all I have. Let's hand it over to Xiaoming. He has some REST API client dashboard set up in his lab.
Okay, sure. Thank you, Perivat. So my name is Xiaoming Zhao. I'm the software engineer of the Refinitiv. So we know the REST API is very powerful. So I just would like to take just a couple minutes to demo one simple example usage of the. So Renee, are you able to see my screen?
Yes, we do.
Okay, cool. So so this is just one example of the REST API usage. So let's say we have the query syntax. This is just one example. So I want to pull, for example, I want to pull the data of the one user, the update rate. So for example, here, let's say, this is my simulation of the test client with a simulation of the data user. So this user now is requesting some specific items from the real market data. Now the data is here, is real. So we see here, use this query, we can see the update rate for this user. And this is the value of the update rate. If I keep or refresh, we can see the value is keep update. So if I stop if the client is dropped, let's say, so it's going to back to 0. Okay. Now let's see. Let me restart the data request from this user. So we can keep update. So is that a better way to keep record of the updated rate change? The answer is yes. We have the way to keep the record change. So this is just one example. So we employ the tools we call, the tools come from the InfluxDB, and there's a telegraph. This is just the daemon application, which simply issues a query, like here, issue the query to the REST API and get a response. The response is something like this is a response. So the telegraph, this daemon, to collect this information and export this data to the InfluxDB. So InfluxDB just time series database. So it saves the data, and some other third-party tool can extract data, or the InfluxDB can inject the data into the graph, so the user has a better understanding. So what is going on of the data come back from the REST API. So give me example, the InfluxDB here. So basically, this is I just show this is update rate from the ADS or the RTC we see. So we can see the data, the InfluxDB up and going. So we kind of we see this trend from the graph. So it's much easier for the customer to see the change. So, and this is just one example. And actually the telegraph is much more powerful beyond the query, the REST API. They can collect all the metrics of the host machine data as well. And we can plug in this data into a bigger picture, for example, here. So we plug in the update rate, this data inside of the whole dashboard. And for example, the dashboard can show all the data. So this is the OS level, the package received, package set, and the CPU usage and the memory usage. So I think this is it's pretty powerful. So some people, some clients really like this strategy. So this is just one example of the REST API. There's much more we can do, and we can put the data into the graph and use it for the customer to use. So thank you. So this concludes my very short demo. Okay, let's move on to the next session. I believe this is going to be the Q&A session and questions coming out. So back to you, Renee.
Thank you, Joe. Thank you. We are in the Q&A session, so if you have some questions, please unmute and raise the questions. And I will ask Joe if you can check the chat for questions, if there are already some, because I'm sorry, I have some weird issue to display the text from the chat. So please, Joe, if there are some questions, if you could moderate this part. And customers who are having questions, please unmute yourself and you can raise the questions over the mic. Joe, do we have some questions in our chat room?
Yeah, so there's a question regarding from Sen. Sen, what wildcard do you support in REST? For example, all equal to all instance. So and others. So Parrot, can you?
Thank you, Sean Mahoney, for the question. I think that's the only wildcard we support. for the share mem resources, we can put instances followed by all, and then the query gonna apply to all instances. I think that's the only one we supporting. I don't recall any other wildcards that we support.
Okay, Joe, do we have some another questions?
Sean got another question.
So let me answer this question. So the question is in paragraph, how often is it practical to pull the REST API? So actually this is purely configurable. So you can pull is 5 seconds, 2 seconds, 1 second, 1 minute. So it's purely configurable. So as long as we don't use too much the CPU bandwidth from the RTC. So it's purely configurable.
So the lowest you can go is 1 second.
Actually, I just test a second. It could be smaller, but the smallest I test just 1 second.
Gotcha.
Sorry, Simon here. Is it likely to add a load to the ADS or the ADH if you keep polling it? You know, sure, if you keep hammering it with REST requests, does it add a load to the ADS or the ADH?
We have a separate REST thread, and then we can bind that thread to a specific CPU core. So for our configuration and share memory resources, it should be handled by the REST thread only.
Okay, so you can protect it. Okay.
Right, but there's an exception, right? For the item database resources, the REST thread had to talk to the item threads, so it could cause some load to the item threads a little bit. So I mean, I would limit it to configs and share memory unless you really want the item DB resources.
Okay, thanks.
And you could lock the ItemDB resources down to just maybe admin access if you're concerned about it. You know, using IP whitelist or security keys.
Good point.
Right. That's how I would go about it. Yeah. And then as far as yeah, there's no reason to go more than lower than once a second. Our shared memory client side only updates once a second anyways. So I think once a second would be the usefulness.
I'm just thinking of the worst case scenario, Joe, where someone tries to, like, a client just tries to hammer it as much as they can, and then
For sure.
and then have problems. Do you know what I mean? And then they'll come through to us.
Yeah. Yeah, as Fairwatch said, you know, if they hammer just with shared memory and config, the only thing you're going to peg is your REST thread.
Okay, good.
So it shouldn't impact the other threads on the machine, as long as you do proper binding.
Yeah. Okay. Thank you.
Good point. Do we have some other questions in queue, Joe? Aribat?
I don't see any other questions.
Okay. Because there are no questions in the chat and no new question raised over the mic. So if all questions are taken, then on the next slide, you can see on the next slide, you can see additional resources and websites where you can learn more about the RTDS REST API. Here is the link to our academic portal and contact my person. So documentation with the full description of the REST API is available at our customer portal on address myrefinitiv.com in the documentation that's called ADH or ADS installation guides. And thank you for joining the session. Thank you for joining the session. Hopefully you will find it useful, and we are looking forward for your questions. I hope we will see you again in the future academic classes, and please provide us feedback about this course, which I will send you over the mail because due to some technical problems on MS Teams, I'm not able to see and I'm not able to send any text over the chat. So to all participants who attended today webinar, I will send email with the link to our customer survey, and please provide us your feedback. Thank you, thank you, thank you for your visit. Thank you for your time.